Okay, guys. So, hi. I'm not sure if you've ever actually seen my face. So I thought maybe I'd put myself in it for like a hot little second. I just got back from my run. And we're going to try to make this work because I left my tripod at school. It is now a Monday evening. Both of my kids are on their devices. We'll see how this goes, okay? So we're going to do page. This is my setup. See, I have the answer key over here. That's to make sure I don't mess up. And then the, the notes that I give you over here. And I try to, follow along over there so I don't do anything silly. But we're going to do page 18, which is the second half of lesson 7. I just have to say, if you are here right now, that means you have gotten up, you have opened your laptop, and I'm very proud of you. I've been telling people that, bragging about you guys, saying that you've been putting a lot of effort, and that's what it takes to get it done. I'm really, really proud of you. Okay, let's go. So, this is a continuation of trying to figure out if an ordered pair, like 2 comma 5, is in fact a solution to a given equation or situation. So what if you don't have a graph to check to see if 2, 5 is on the line? Well, you could potentially graph this, but there's other ways around it. So what we're going to do is we're going to write down this equation. So take this, box it off. Hold the phone. Okay, and then this is the point that we're going to see if that is actually a solution. Okay, so step 1, you're going to write down the equation y equals 3x minus 1. There goes my battery. Boom. The second thing you're going to do is determine which of these two numbers is the x value and which of these two numbers is the y value. So remember we talked in class a couple Fridays ago or something, well, that the x is the first number in an ordered pair and that the y value is the second number in the ordered pair. So what we're going to do is for step 2, wherever we see a y, we're going to replace it with the number 5, and wherever we see an x, we're going to replace it with the number 2. So step 2, take the y, and you're going to substitute. Instead of y, you're going to replace y with 5. Equals 3. Now that's 3 times x. So we're going to do 3 times 2 minus 1. So that's the substitution line. Then I'm going to simplify each side. Well, the left-hand side is a 5. That's it, right? But on the right-hand side, order of operations, multiply 3 times 2 first, 6 minus 1, and then 6 minus 1 comes out to be 5. So what you can see is this is called a statement. This says 5 equals 5. Is that true? This is true. 5 does equal 5. So I'm going to put a little check. Yay! So you're going to say, yes, 2 comma 5 is a solution. Yes, 2 comma 5 is a solution. And you could say to the equation y equals 3x minus 1. When you substitute 2, 5 into the equation, it makes the equation true. Substituting. I'm just changing this for my notes a little bit. 2 comma 5 into the equation makes the equation true, or results in a true statement. But I think you would probably feel more comfortable this way. Makes the equation true. Okay, so yes, 2 comma 5 is a solution. That says substituting 2 comma 5. That's a lousy 5. Hello. Okay. Oh, improvement, but not quite there. Substituting 2 comma 5 into the equation makes the equation true. So that means that if you were to graph this line, that 2, 5 would be on the line. Does the 0.71 lie on the line defined by y equals 2x plus 5? So let's see. Off the cuff here. Let's make this about, I don't know, how about lemonade? So if this was about lemonade, this would mean that the girls started with $5, right? And that they were charging $2 a glass. Now what this means is if they sold 7 glasses, follow me here, follow me. X is 7. That means 2 times 7 glasses, hello. They sold 7 glasses that they're only going to make at the end in their cash drawer $1. I mean, we can do this in our head if I relate it to lemonade. Am I right? How can they sell 7 glasses plus have the $5 to start and only result with an output of 1? Like, they're going to have a lot more than 1. They started out with $5. Okay, so let's pretend that the lemonade does not make sense, and I'll show you the mathy way to do it. First thing you're going to do is you're going to write down the equation. Y equals 2x, what is it, plus 5, right? That was like the donation at the beginning, right? Substitute in, so 2 times 7 plus 5. Does that come out to be 1? I don't think so. So 1 equals, you can tell right now. 2 times 7, 14, plus 5, 19. That's a no way, not true, right? So this is, 1 does not equal 19. So this is not a true statement. Well, this is true. Let's put it here. 1 equals 19 is not a true statement, right? So this means that the point 7, 1 does not lie on that line. It is not a solution. You can say it's not a solution because substituting in the values results in a false statement. Because, woohoo, makes a false statement. You can say results in a false statement. You could say I got 1 equals 19. I know that's not true. Some variation of that. So then we get into Crazyland USA, and we've got this equation, which for me becomes very hard to make about lemonade unless I put it in this y equals format. So we're going to talk about that coming up, how we're going to put this in our general format over here, because it makes everything easier to understand. So I'm going to have to go ahead and rely on these 3 steps and not on the lemonade story to help me out here. Because sometimes you do need a little bit, it's called a algorithm. So here we go. 1, write down the equation. What is it? 3x minus y equals 3. Okay. Go to your point, which is hither. That's the x, and that's the y. Second step is to substitute in. So wherever you see an x, right there's 1, you're going to replace it with a 2. And wherever you see a y, you're going to replace it with -3. So let's do this. It's going to be 3 times x minus y. Well, it's minus y, and y is -3. So minus -3. Oh, we talked about that. Do you remember when we did integers and I said, this is the one thing everybody struggles with, especially when you substitute? We said this. We talked about this. Minus a negative. And I was like, oh, I remember when this stuck for me because my teacher said, like, you take this little dash here and this little dash here, and they kind of come together and make it like a plus. That's like the best way, but I remember the day that stuck. Subtracting a negative is the same as adding a positive. So we could just say 6 plus 3, right? Or 6 plus positive 3 equals 3. No. But this is a trick question because you can see people would probably do 6 minus 3 and then think this was true. But it's not. 9 equals 3 is not true. Therefore, the point 2, -3 is not going to lie on that line. You could really say the point, or really should say the point 2, -3 is not a solution to the equation. What are we at? 9:55. We're almost at 10 minutes. 3x minus y equals 3. Okay. I think you might have had enough. Oh, and how do you know? Because when you substitute 2, -3 into the equation, the resulting statement is not true. I'm going to try to cut off this video. It's 10 minutes in. Why don't you do number 4 we're going to call it homework because it just makes sense. But you know I mean independent practice, right? Try this one out. Follow these steps as I did up here. Just be very careful when you substitute in for X and Y that you put them in the right spot. And don't be afraid of this guy right here. So this is a fraction, but it works out really nice. See, there's a 5 here. It works out. But do your best. At the very least, we should be able to at least get through step 2 with the substitution. Thanks for showing up. It's the most important step. See you later.